my 1.6. 1 through 4, we're all dealing with radical equations. The square root of 40 minus 3x equals x. These are the kinds where you have to check your solutions each time because weird things can happen underneath the radical. If you have any problems with any of these, you need to go look at Thomas's. I explain them more fully in Thomas's section. Got to square both sides. So squaring and unsquaring will cancel each other out. We have an x squared equation. So let's get ready to factor. I'm bringing everything over to join the x squared. So the x squared is there. The minus 3x will turn into a plus 3x. The positive 40 will turn into a minus 40. Now we need to factor. Signs need to be different. What two numbers multiply to give you 40, whose difference is 3? That's 5 and 8. 8 is the big number. He needs to go on the plus sign. Set each piece equal to 0. X is 5. X is negative 8. We need to check both. Plugging it in here. 40 minus 3 times negative 8 equals negative 8. It gives us 40 plus 24 equals negative 8. The square root of 64 equals negative 8. That's not true. We didn't put the radical on there, so we only take the principal square root, which is the positive one. Let's check 5. 40 minus 3 times 5 equals 5. 40 minus 15 equals 5. Square root of 25 equals 5. So 5 is a good number. Number 2, square root of 4x plus 44 equals x plus 8. This guy is all by himself. We're ready to square both sides. So we end up with 4x plus 44 here. X plus 8 foiled out. You can foil it yourself, or you can go remember what you got in your notes from Thomas's. Will give us x squared plus 16x plus 64. Move over the 4x and the 44. X squared plus 12x plus 20 equals 0. There's the 0. Let's factor it. X plus x plus. The two numbers that multiply to give us 20 that add together to give us 12 are 10 and 2. Use the property that allows you to set each piece equal to 0, and then we'll need to check. So 4 times negative 10 plus 44 equals negative 10 plus 8. So we get negative 40 plus 44 equals negative 2. The square root of 4 equals negative 2. That's not going to work for the same reason the 64 didn't work. 2 doesn't equal negative 2, so kill that one. Let's look at checking the negative 2. Square root of 4 times negative 2 plus 44 equals negative 2 plus 8. The square root of negative 8 plus 44 equals 6. The square root of 36 equals 6. So negative 2 is a good answer. Number 3, the square root of 2x plus 5 equals x. Isolate this radical by sending the 5 over. And then we're in the same boat we were in number 2. This should be extended there. Square that, square that. We get plain old 2x plus 5. Over here, this is a FOIL problem. X squared minus 10x plus 25. Remember, it means to say x minus 5 times x minus 5, and then FOIL it out. Move these guys over, minus 2x and minus 5. So we get x squared minus 12x plus 20 equals 0. We're going to end up with the same factoring problem as the previous problem, except we've got a minus here. Set up two sets of parentheses. The signs need to match, and they both need to be negative. What two numbers multiply to give you 20 that add together to give you 12? So we get 10 and 2. Let's go up here. X minus 10 equals 0. X minus 2 equals 0. So x is a 10, and x is a 2 when you send them to the other side. Let's do the checks. Square root of 2 times 10 plus 5 equals 10. That's 25 plus 5. This is 5 plus 5 equals 10, so 10 works. Let's see if 2 works. The square root of 2 times 2 plus 5 equals 2. This is 4 plus 9. This is 3 plus 5 equals 2. No, that didn't work. So 10 is the only one that worked there. Last one in this group of first problems. Square root of 9x plus 9 equals x plus 5. We need to isolate this guy. Let me scoot us down. Now that we're just about through, I'm remembering that almost every time. Move the 9 over. We get the square root of 9x equals x minus 4. Squaring and unsquaring cancels each other out. This is a FOIL problem. X minus 4 times x minus 4 will give you x squared minus 4x, and then plus 16. Move the 9x over. X squared minus 17x plus 16 equals 0. X and x, signs need to be the same and they need to be negative. You're looking for two numbers that multiply to give you 16, that add together to give you 17. Set each piece equal to 0 and solve. And then on these, we need to check them. So we've got, on the check, we've got the square root of 9 times 16 equals, is that how it started? No, not a big deal. Let's go ahead and stick with the first one. Plus 9 equals 16 plus 5, putting in right up here where the x's are. 9 times 16, 144, plus 9 equals 21. That comes out as a 12. 12 plus 9 equals 21, so that guy works. Let's check the 1 up in here. Square root of 9 times 1 plus 9 equals 1 plus 5. Square root of 9 plus 9 equals 6. 3 plus 9 equals 6. No, that one didn't work. Okay, 5, 6, 7, and 8 all have exponents that are rational, meaning they're fractions. So we're going to have to multiply times the reciprocal. In order to make this say x equals, we need it to be x to the first. We're going to have to make that 5/3 be a 1. Multiply times is reciprocal, so times 3/5. We'll do the same thing on both sides. Whatever you do on one side, you have to do to both sides. So 5/3 times 3/5, you can check your calculator, or the 5's cancel, the 3's cancel, and we get a 1. Over here, put 32 in there. The denominator is the index, and then we'll raise it up to the third power. The 5th root of 32, check on your calculator. If you don't know, it's a 2. 5th root of 32 equals 2. So we've got 2 to the third power, and that gives us an 8. Number 6. We've got x minus 7 raised to the 3/2 power equals 64. Again, we want to get that to be a 1. We want that exponent to be a 1. So we're going to raise it to the 2/3 power. Whatever we do to one side, we have to do to both sides. 3 over 2 times 2 over 3 becomes a 1. So we get x minus 7. 64 raised to the third power, or to the 2/3 power. Denominator is the index, raise it to the second power, raise it to the numerator. Cube root of 64 is a 4, 4 squared is 16. You can also raise it to the 2/3 power. 64, Humpy, 2, ABC 3, and that'll give you 16. X minus 7, we're trying to solve for x, so add 7 to both sides, and we get x equals 23, and that's a good answer. We don't have to check. One's like, we only have to check ones like 1 through 4, where you've got a radical and that you're squaring in the problem. Number 7, 2x to the 1/2 power minus 6 equals 0. I've written that I knew there was something funny while I was checking my notes. I wrote that problem incorrectly on my worksheet. It's 11/2, and that's going to matter because you're going to have one like that on your homework, and I want to be sure you're prepared for that. Okay, so let's get this x raised to the exponent by itself. Move the 6 over first. Divide by 2. So now we've got him by himself, and what we're going to do is raise him up to the reciprocal power. Raise this up to the 2/11. 11/2 times his reciprocal will give us a 1. We're going to have to raise that guy to his power also. So x equals, put the 3 under the radical, the denominator is the index, and then you can put the 2 there, or you can put the 2 on the outside. If you put the 2 in there, just change that to a 9. So the 11th root of 9 is your answer on that one. Number 8, we've got x minus 1 raised to the 2/3 power equals 121. There's a little bit funky thing going on in here. Let's take this just like normal, raise it to the 3/2 power. Whatever you do to one side, you have to do to both sides. These two become a 1, so we have x minus 1. Over here, when we put 121 here, this denominator is an even index, and like I went over and over in Thomas's, when you have an even index and you put on the radical, you're going to need to put plus or minus on it. So let's continue doing this setup. The denominator is the index, and then whatever we get, we will raise to the 3rd power. But because we put on the radical and it's an even index, a 2, a 4, a 6, we're going to have to consider both the positive and negative versions. So x minus 1 will equal plus or minus. The square root of 121 is an 11, and then 11 to the 3rd power is 1331. So because we can do all of this, we need to. We'll be moving this 1 over. So x equals positive or negative 1331 plus 1. So let's separate those out into the positive version of 1331 plus 1 and the negative version of 1331 plus 1. So this will give us 1332, and that will give us negative 1330. So we get those two kind of odd answers, 1332 and negative 1330. Okay, last 4 problems are the mu problems, where you've got to set up your own let mu equal. These you might want to go back and look at Thomas's just for clarity. He practices, I think we did 2 there. We're doing 4 here, so your homework really emphasizes these problems. And so your test will also. X to the 4th, change this problem to negative 257x squared plus 256 equals 0. That's it correctly written. Okay, let's see. Let's do our change up. We've got a problem here because this is not a normal squared and x to the 1st power, so we're going to need to do some substituting. Remember, you're going to grab that one each time. 0 equals 256, no problem, plus sign, no problem. Oh, there's an x squared. Put a mu in its place. 257, negative sign. This is x squared squared, so it'll be this guy squared. And now if you look, we've got exactly what we're used to. It's just with this funky variable. Mu and mu, signs need to be the same and they need to be negative. What will multiply to give you 256 and add together to give you 257? It'd be 256 and 1. Set each piece equal to 0. And solve. And remember, you're not done yet because this problem started out talking about x's. Just for grins, remember we're looking for 4 answers. But we've converted it to mu's. We've got to convert it back now. So in place of the mu, replace it back x squared equals 256. X squared equals 1. And now you know from what we did in Thomas's work, we need to now take the square root of everybody. You want to get x. So you're unsquaring a square. There's x. The square root of 256. Got the square root of 256 equals 16. You put the radical on with an even index, so it's going to be a plus or minus 16. And x equals the square root of 1 is positive or negative 1. So there are the 4 answers this one has. Let's look at number 10. X minus 17 on the square root of x plus 52 equals 0. This is not normal, so this is a quadratic in form. It's a quadratic wannabe. Let mu equal that piece, whatever sits behind the b. So square root of x. Let's go in and substitute anytime we find x's. Start at the back, it's easier. 52 plus, oh, there's our guy. Substitute in a mu, then a negative 17 in front of that, and then this is the square of that, so we want to put the square of our mu. It'll always start with the mu squared. You don't have to worry about that part. Okay. Mu and mu, signs need to be the same and they need to be negative. We're looking for two numbers that multiply to give you 52, that add together to give you 17, and that's going to be 13 times 4, or 13 plus 4. 13 times 4 is 52, like deck of cards. You got 13 cards in each suit and 4 suits. And then 13 plus 4 will give you 17. So let's plop them down there. Doesn't matter which one goes where. Set each piece equal to 0. And then send them across. Now, we're not dealing in mu in this problem, we're dealing in x. So you want to go and resubstitute. So we're going to plop back in the square root of x equals 4. The square root of x equals 13. You know from this set of problems, from 1, 2, and 3, and maybe even 4, that you're going to have to square both sides. So squaring and unsquaring cancels each other. We get 2 answers there, 16 and 169. Those are both good answers. And you are good to go. Let's look at number 11. I feel like there's something. No, we're good. Okay. Number 11. We've got 6x to the 2/3 power minus 29x to the 1/3 power minus 5 equals 0. Another odd looking, sort of like if you fuzzy your eyes, that looks quadratic. It looks like something to factor, but it doesn't look quite right. So let's let mu equal that piece, x to the 1/3, and let's go substituting. 0, negative 5, oh, there it is. Plug in mu in its place. 29 minus, oh, there's it squared, so mu squared. Don't forget the 6. Let's factor this. Okay, what we want to do here is, I need 29 out of 6 and 5. So I know I'm going to be putting 6s and 1s or 2s and 3s, but I know that 6 times 5 will get awfully close to 30. So I'm going to try 6 mu and mu. Signs need to be different. 5 there, I can get a negative 30 out of that. Put a 1 there. So the outside is a negative 30 mu. The inside is a plus 1 mu. That's exactly what we're looking for the middle term, so I know this is good. So 6 mu plus 1 equals 0. Mu minus 5 equals 0. Mu is 5. Move the 1 over and divide by 6. So we're getting negative 1/6 and a positive 5. You know we've got to do switcheroo, get back into the land of x's. So instead of mu equals negative 1/6, we're going to have x to the 1/3 equals negative 1/6, and we're going to have x to the 1/3 equals 5. So on the previous number 5, 6, 7, and 8, you learned what to do with an exponent that is on a radical exponent. It's multiply times is reciprocal, times 3 over 1. If you do it to one side, you got to do it to both sides. Keep moving. All this, 5, where'd that come from? Okay, those will cancel. 1/3 of 3 is a 1, so we get x equals a negative cubed is a negative, 1 cubed is a 1, 6 cubed is 216. Over here, 1/3 times 3 cancels out. 5 to the 3rd power is 125. So we get those two answers. Let's look at number 12. Got x plus 3 squared plus 4 times x plus 3 plus 3 equals 0. Okay, again, we've got like an x squared plus 4x plus 3. It's the workings of a quadratic. Let's substitute so we can make it look better. It's always going to be what's behind the b. So that'll be every time we see an x plus 3, we'll substitute in a mu. Oh, there's an x plus 3, so substitute in a mu. 4 in front of it, plus sign in front of that. Then this is our mu squared. Now we need to factor this. Signs need to be the same and they need to be positive. What two numbers multiply to give you, let me pull this down here. Multiply to give you 3 and add together to give you 4. That's 3 and a 1. So mu plus 3 equals 0. Mu plus 1 equals 0. We're doing the same thing, different ways. Now you got a problem. You look like you're done, but this is a problem about x's. So bring this back down here, and in place of mu, put an x plus 3. So we've got x plus 3 equals negative 3, and in place of mu, put x plus 3 equals negative 1. Get x by itself. So minus 3, we get x equals negative 6. Minus 3, we get x equals negative 4. And both of those are good answers. See you next time.